Section 3.3, linear functions. These are the type of functions whose graph happens to be a line. That's why it's called linear. This is how a linear function looks like. F of x equals a of x, a times x plus b, where a and b are constants. Keep in mind, f of x is just a nickname for y. In other words, alternatively, I can write this as y equals ax plus b. Okay, so a couple of notes about linear function. One of them is the graph of linear function is always a line. Rain or shine, it's a line. It's not a point, it's not a curve, it's a line. The domain of these guys, the values you can choose for x, is always all real numbers. Any number from negative infinity to infinity will do the job. For instance, these are all examples of linear function. F of x equals 3x minus 1. F of x equals 5/2 x. F of x equals negative 3. Notice the function can be constant as well. So in this case, let's say your a is 3, your b is negative 1. Here your a is 5/2. There is no b. Here a is 0, but b is negative 3, comparing to the general form of a linear equation. So what we like to do, part of this section, is what? Graph these kind of linear equation. Remember, they happen to be a line. So what we do, we plot points. So this is like method number 1. There are 3 ways to graph a line. So here is the, I would call it primitive way, which is it takes forever. So it's a time consuming. But we have a better way to graph a line, which is coming up next. Okay, let's say we select some garden variety of numbers like negative 1, 0, 1, 2. Remember, I chose these numbers from top of my head. So now I'm going to go back to this equation, replace the x with negative 1. So I'm going to get y equals 2 times negative 1 minus 4, which is negative 6. Then with 0, so I'm going to get negative 4. Then with 1, then I'm going to get what? Negative 2. Then with 2, then I'm going to get what? 0. So if I was going to plot these points, or I should say put these dots on the x and y axis, what would I end up with? Let's see now. Negative 1, negative 6. 1, 2, 3, 4, 5, 6. 0, negative 4. 1, 2, 3, 4. 1, negative 2, right about here, and 2, 0, right about there. So if I would put my straight edge and, connect the dots in a very straight line, lo and behold, as I expected or suspected, the graph is going to be called a line. So a line is a straight curve, yes? So it's a straight. How about this guy? F of x equals negative 5/2 times x. Okay, if x is what? Negative 2, I get negative 5/2 times negative 2. Remember, this is multiplication of fractions. So I can what? Cross out the 2's, I get 5. Y is equal to negative 5/2 times 0 is 2. Y is equal to negative 5/2 times 2. The 2's cancel, I get negative 5, and y is equal to 5/2 times 4. Okay, 2 goes into 4 twice, so you get negative 10. So now we are ready to what? Plot the dots, connect the dots, and what do we come up with? What do we expect to come up with? A line, right? So let's see if we do. Negative 2, right? 5, 1, 2, 3, 4, 5. 0, 0, so you're at the origin. 2, negative 5, 2, 1, 2, 3, 4, 5. And 4, negative 10, 2, 3, 4. This is 5, then you go 1, 2, 3, 4, 5, 5 more down. So if you connect the dots, lo and behold, you should have a what? Straight line, and I do, and there it is. Okay. So there you have it. This is like method number 1. All right. Method number, sometimes the equation comes up in this format, which this format is general or standard form of a linear function, which is ax plus by equals c, a, b, c are constant. In other words, sometimes instead of y on one side, you have x and y on the same side and the number on the other side. So what you do is either you solve this equation for y, or just plot the values of x as you see it in the equation. For instance, remember, so this would be like what? 2x minus y is equal to 4, correct? So if x is equal to -2, okay, this would be like -4 minus y is equal to 4. So if you add 4, I get what? -y is equal to 8. Divide both sides by -1. Y is equal to negative what? 8. Right here. Alternatively, you can take this equation using the skills we learned in section 2.2, solving the equation for a specific letter. You can just solve this for y. Subtract 2x. Excuse me, and you get -y is equal to -2x plus 4. Divide both sides by -1, you get y is equal to 2x minus 4. Or you could use this equation, okay? This guy is called slope-intercept form. This guy is called standard form. So a standard form is when the x's and y's are on one side, the number is on the other side. Whereas if y is all by itself on one side, that's called slope-intercept form. We're going to get to that in a minute. Okay, so I'm going to use this form because this is much easier, correct? So if x is -2, I get -6. If x is 0, I get -4. If x is 1, I get -2. And you can plot the dots and get yourself a nice line like -2, 1, 2, 3, 4, 5, 6, 7, 8, -1, 1, 2, 3, 4, 5, 6, 0, 1, 2, and 1, -2, and so on and so forth. So if you connect the dots, lo and behold, once again, you get what? Straight line, as I have. So there is a little slightly better way to do this, and that's called by x and y intercept. Excuse me. X-intercept is the point where the line crosses the x-axis. So that's called x-intercept. And notice any point on the x-axis has a what? Y equal to 0. Always, rain or shine. Any of these points on the y-axis, on the x-axis, happens to have a y component equal to 0, correct? So the point on the line whose y is equal to 0 is called x-intercept. In other words, this is the point where the line crosses the what? X-axis. This is the point where the line crosses the y-axis, and notice on that particular point, x is equal to 0, because any point along the y-axis has a x equals 0 as its component. So with that in mind, how would you go finding the x and y intercept of this graph? Remember, f of x is just a nickname for y. So the way you find x-intercept, you set what? Y equal to 0 and solve what? For x. So in this case, I get 3x minus 6. So that's like 6 is equal to 3x, divide both sides by 3, x is equal to 2. So what are you saying? I'm saying the x-intercept is 2, 0. Remember, the reason we came up with 2 was because we set y equal to 0. For y-intercept, we set what? X equal to 0 and what? Solve for y, correct? So that would be like what? Y equals 3 times 0 minus 6, so y is equal to -6. So the y-intercept is 0, -6. Remember, once again, the reason we came up with -6 because we set x equal to 0, correct? So all you have to do is go, what, 2 units over, 6 units below the x-axis, 1, 2, 3, 4, 5, 6. Okay, connect these dots and continue the line. So don't stop, keep going, right? So keep going on both directions because the line is a never-ending line, right? It never ends. So don't just connect this and forget about the other halves of the line. So once again, this is the picture of a line. So very good. So that's pretty much that section. And now let's do this guy. You know, the continuation of that section. Graph this using the x and y intercept. Once again, you set y equal to 0, solve for x, correct? So this would be what? 0 equals negative half of x plus 5. So if you subtract 5 from both sides, you get this, correct? And if you multiply both sides by, say, negative 2, okay, you end up with what? 10 is equal to x because the 2's cancel, negative times negative is positive. So there you have it. So the x-intercept happens to be 10 comma 0. Remember, this is exactly the same as y is equal to negative half of x plus 5, correct? So if you set y equal to 0, x is equal to positive 10. On the other hand, for y-intercept, what we do is set x equal to 0. What does that mean? That means you replace the x with 0, excuse me, in this equation and find out what y is equal to. And turns out y is 5. So the y-intercept is 0, 5. Do you see it? So you go over 10 units on the x-axis, up 5 units on the y-axis, connect the dots and continue the dots. So there you have it. And once again, rain or shine, the graph is what? Straight line. Excuse me. So now we'd like to take a look at special graphs. What happens when y is a constant? In other words, x is missing. What happens, what kind of a graph do you get when y is missing from the equation, such as f of x is equal to 3 or x is equal to negative 2? How would the picture of these guys look like? Well, it turns out when you say f of x is equal to 3, what you're saying is y is equal to 3, what? No matter what the value of x is. In other words, x can be any real number, but rain or shine, y stays at 3. So what you do, you go up 3 on the y-axis, right about here. So when you say x can be any real number, so that means you can go sideways, either way, forever. So there it is. And this kind of line is called horizontal line or flat line. Later on in the upcoming sections, we'll see the slope of this line is 0. So it's flat. However, when you say x equals negative 2, that means x is equal to negative 2, what? No matter what the value of y is. So what do? I go 2 units to the left on the what? X-axis. And when you say no matter what the value of y is, that means you can go up and down as your heart desires. So what happens is the line looks like this, and that is called vertical line. So when x is missing from the equation, the line is flat. When y is missing from the equation, the line is vertical. As a matter of fact, later on we'll see the slope of this guy, as I mentioned, is 0, and the slope of this vertical line is undefined. And that's pretty much the gist of what this section is, and thank you.